Hi kids, this is William from Beyond Infinity. Are you ever confused about algebra and find it hard to use it or picture it in your head? How about I tell you a single method to solve all these different maths problems that come your way? This method is called a bar method. Want to learn more? Let's get started. Suppose you have this maths problem. Jim has $13 more than Peter and together they have $35. How much does Jim have? Maybe you have this problem and you ask your older siblings or your tutors, and they may say, well, you can just let Peter be x, and then we can turn the question into equation 2x plus 13 equals 35, swap the numbers around and solve and get x equals 21. So Jim has $24. Boom! You'd be like, what? That's so confusing. Yes, replacing numbers with letters is not an exactly easy concept to learn, so don't worry, you're not alone. But what can we do? Well, never fear, because the bar is here. I'll show you how you can use a few bars, quite like this cute one over here, to solve this problem in no time. So, let's try it. We have the same question here. We will start with the first part. Jim has $13 more than Peter. So let's draw two bars to represent the amount of money that each person has. We'll draw one for Peter like this and one for Jim like this. Jim's bar is longer because we know that Jim has more money. Now, if we align the bar and draw a line here where Peter's bar ends, the part of Jim's bar on the right of the line is the extra money that Jim has compared to Peter, which is 13. The part on the left then has the same length as Peter's bar. This part is therefore Peter, like this. Now, the question says that together they have $35. This means that if we put the two bars together like this part is Jim, and this part is Peter, and the total length of this combined long bar would be 35. But we know that the right end of this bar is 13. This means that this part of the bar is 35 minus 13 equals 22. But this is also the length of two Peter's bars. That means that this part, which is Peter, is 11. And therefore, Jim is 11 plus 13 equals 24. Simple, isn't it? By converting the amount of money into the length of the bar, we have easily solved this problem. Now, the great thing about the bar method is that it can be used in many different math problems, as long as there are a number of unknowns and some kind of relationship between them. Let's now look at a slightly more complex problem. James is 5 years older than Thomas, but 3 years younger than Gordon. The three of them add up to 73 years old. How old is Gordon? Well, an age problem. You can pause the video and see if you can solve it by yourself first. Now, bar methods are especially good for age problems. We can, like we did before, have the bar represent the age of each person. We will draw a bar for James, a bar for Thomas, which is shorter because James is older, and the longest bar for Gordon since he is the oldest of all, like this. Now, let's align the bars. By drawing a line here and here. Now, comparing the length of James's and Thomas's bars, we know that this part is 5. And this part is essentially Thomas. Looking at Gordon's bar, we know that this part is 3. This is how much Gordon has more than James. And this part, looking at the length of the bar, is actually Thomas. And the part in the between, again, because we have aligned the bars correctly, we see that the length of this part is equal to 5. And we'll label Thomas's bar as well. So now we have 3 bars, James, Thomas, and Gordon, representing their ages. Now, let's look at the second part of the question. The 3 of them add up to 73 years old. So this means that if we put James and Thomas and Gordon bars together, the total length is 73, like this. Now, these bars are kind of like Lego, right? So you can rearrange them however you want. So we can do this. We can group all the Thomases together and the numbers together, and the length of this is still 73. But now we can see that since the right-handmost parts are 5, 5, and 3, which adds up to 13, this other part would have a length of 73 minus 13 equals 60. But this part we know is made up of 3 Thomases. So this means each Thomas bar is 20, and therefore Gordon is 20 plus 5 plus 3 equals to 28 years old. Very good. But wait, there's more. Bar methods are also extremely good at solving fraction problems. Another branch of maths that may be making your head explode. Let's see how we can solve fraction problems with a bar. 1/9 of the shirts sold at Peter's shop are striped. 5/8 of the remaining are printed, and the rest are plain colored. If Peter's shop has 81 plain color shirts, how many more printed shirts than plain color shirts does the shop have? Well, that's a mouthful, isn't it? And it looks very confusing. But don't fret, let's just draw a bar. And we will draw this bar. The length of this bar represents the total number of shirts Peter's shop has. Now, the first part of the question says that 1/9 of the shirts are striped. So let's divide this bar into 9 equal parts, like this. And 1/9, which is the shaded part, is striped. Now, 5/8 of the remainder are printed. If we look at the bar now, just by pure coincidence, or maybe just how the question is designed, the remaining bars here that is not shaded actually already has 8 equal parts. So that means 5 of these parts can be shaded, and that would be our printed shirt. And whatever is left is the plain color shirts. Finally, the last part of the question says that Peter's shop has 81 plain color shirts. Looking at the bar, this means that the length of this part is 81. But this part is actually divided into 3, what we did before. That means that each of these parts here is 81 divided by 3 equals 27. But remember, we have actually equally divided the whole bar. This means that the rest of these parts is also 27. Now, to find out how many more printed shirt Peter's shop has, we just have to look here and see that the printed shirts takes up 5 parts of the bar, and the plain color shirt takes up 3 parts. This means the printed shirt has 2 more parts than the plain color shirts, and since each part is 27, we've just found out, the answer we're looking for is 27 times 2. That's 54 more shirts than plain color shirts. So by using a bar, we have again arrived at the answer. Very simple without fraction multiplication and division that may be making your head explode. Now, of course, once you're familiar with algebra or fraction multiplications and divisions and all that, it is still more efficient to work out the problem that way. It does take some time to draw the bar and label them, so it's easier if you can just write down the numbers and do it. But if you're confused about these concepts and not ready yet, you can always come back to the bars and the solution will be easily laid out for you. Let us now finally look at one complex problem that makes use of all these properties of the bar method. And the problem goes like this. Gary and Henry brought an equal amount of money for shopping. Gary spent $90 and Henry spent $350. And after that, Henry had 4/7 of what Gary had left. How much money did Gary have after shopping? Again, you can pause the video here and see if you can solve it for yourself using what I've taught you so far about the bar method. Alright, now, you might have been complaining. I can't really draw perfect bars that perfectly align, perfectly square like this, so how can I use this? Well, to show you that you don't actually need perfect bars, here I'm going to solve this problem with hand-drawn bars. So again, let's start with drawing two bars. One bar for Gary, hand-drawn, and one for Henry. The bar will represent what they had initially, and we know that these two bars have exactly the same length. Well, it's hand-drawn, so it's not exactly the same length, but we know that we've drawn this to be exactly the same length because they represent the initial amount of money that Gary and Henry have, which is equal. Now, the second part of the question says Gary spent $95. So Gary spent $95, and we'll draw a line somewhere here. And this part of the bar, the 95, represent how much Gary has spent. We do the same thing for Henry. He spent $350, so we write 350 here. And we know that 350 is more than 95, so I'll draw a line somewhere here. And so this part represents the money that Henry has spent. Now, we can align the bars like this so that we can get the lengths of the different parts. And if we look at this, we see that this part is actually 95. And so the remaining part on Henry's spent bar is 350 minus 95 equals 255. And because we have aligned the bars, we can now label this length on Gary's bar to be 255 as well. These two parts have an equal length. Now, the final part of the question. After Henry has spent his money, what he had is 4/7 of what Gary had left. Now, what Gary has left is this, and what Henry has left is this length. So this means that if we divide Gary's leftover bar into 7 parts, the length of Henry's bar will take 4 parts. So we could do that. We can divide Gary's bar like this. So you see that we've drawn 4 parts. In the first part of Gary's bar, which has exactly the same length as Henry's leftover bar, and the other 3 parts is within this length of 255. Now remember, these 3 parts in the length of 255 is equal parts. So each of these parts is actually 255 divided by 3, which is equal to 85. But we've just said that we've used these equal parts, 7 of them, to divide Gary's leftover bar, which means Gary actually has 7 parts of 85, which is 7 times 85 equals $595 left after he spent $95. What a rich man. But see how you can use this powerful bar method to make such a complex problem simple to solve. So let's recap. To use the bar method, We first draw a bar for each unknown with the length representing the value of the unknown, or the original, or representing the whole, depending on the type of question you're doing. Next, you can align the bars and label overlapping parts with known information. This part should just be simple arithmetics, just like measuring the length of a bar. Next, perform your operations necessary, combining bars, rearranging the bars, making new bars from old bars, or divide the bars into equal parts, etc. And find out the length of different parts of the bar using the information given in the question. And finally, with enough information, you will be able to find out the length of the bar you're interested in, giving you the solution to your problem. Alright, I hope you learned how to use the bar method today. To test how much you know, here is a question for you to solve with the bar method. Leave your answer in the comment section and I will tell you whether you're correct. If you like this video, don't forget to like and subscribe to our channel Beyond Infinity. I'm William and I'll see you in the next video.